Okay, our topic for today has to do with cross sections of three-dimensional shapes. Our essential question and the whole point of this is I need to know, can you describe the two-dimensional figures that result from slicing three-dimensional figures? So before we get into the actual slicing of three-dimensional figures, there's some vocab words that I need you to make sure you know prior to doing that. So right here, when things are side by side and equal distance apart and they're never ever crossing, that means they're parallel. Okay? So you'll notice sometimes when you, if you have two lines right here and you see these little triangle looking things or little tick marks that match right there, that means that the lines are parallel. So in this particular case, this means line Q is parallel to line R. Okay? Another way, if they don't have the little triangle looking matching things or tick marks that match, another way that they can say that two lines are parallel is just by simply stating line Q is parallel to line R. And it kind of looks like a little 11 like that, but that in this context means parallel. Line Q is parallel to line R. Okay, something that kind of goes, something that's kind of like not really opposite, but something that goes along the lines of that vocab has to do with this. When two things meet and form a 90-degree angle, that means they're perpendicular. Okay? And this symbol right there means that that forms a 90-degree angle. If you have a 90-degree angle there, you also have a 90-degree angle here, and also right there. But just one right there would suffice. And that would be that this means line P is perpendicular to line T. Okay? And another symbol that you'll notice is sometimes they'll just state it. Line T is perpendicular. This means perpendicular. It's like an upside down T to line P. Okay? That means the same thing. All right, horizontal, that's another word that you should hopefully be familiar with. Horizontal looks like this, okay? And I'd say that it's parallel to like the flat ground. Okay? And when it goes up and down like this, that's vertical, okay? And that would just mean it's perpendicular to the ground. Oops, I think I spelled that wrong. Perpendicular. Okay. All right. So a geometric plane or just a plain old plane, it's not an airplane, even though it's spelled the same way. In geometry, it's a flat two-dimensional surface that extends forever in all directions. Okay. So I would just kind of picture it like as just a flat piece of paper that extends, you know, forever and ever. And you're going to kind of think of it, it's invisible. A geometric plane, you can think of it as being invisible. It goes on forever and ever, but it's like slicing something. So if you're still unsure about what I'm talking about, on your assignment right here, see this thing that's like slicing it? That's a plane, okay? And you're gonna picture that it goes on forever and ever and it's like straight, goes on forever in all directions, okay? So that's what a geometric plane is. The next word that you need to know, the definition is the intersection of a solid figure and a geometric plane. So where they cross. And it's gonna be the shape that's formed when you cut straight through an object, okay? Same thing. And that's called a cross section. Okay? I'm going to show you a quick little YouTube video. It's 1.5 minutes long.
Math shorts. Slicing solid, three-dimensional figures results in different two-dimensional shapes, depending on how you slice them. If you cut through a cylinder with a geometric plane parallel to the cylinder's base, the two-dimensional cross-section is a circle. Any way you slice it, you can get two-dimensional shapes from three-dimensional figures. When you slice a cylinder from top to bottom that is perpendicular to its base, then look at the cross-section straight on. You get a rectangle. What happens when you slice a square pyramid? If you slice across the pyramid with your plane parallel to the pyramid's base, the cross-section is a square. If you slice with your plane perpendicular to the pyramid's base, the cross-section is a triangle. Remember, you're slicing a solid, three-dimensional figure with a geometric plane. You can slice in any direction. Just keep in mind that shapes can look different when you look at them from different angles. So orient the cross-section on the geometric plane. Slicing diagonally can produce different shapes, such as an ellipse or a trapezoid. Understanding the two-dimensional shapes that result from slicing solid, three-dimensional figures is important for geometry and ninjas.
Okay, so this is that was a math short video. I just want to make sure I credit them. I just want you to answer yes or no to this question. Did you watch this video? So right here, thing I want you to add to your notes is I want you to make sure to write that it's parallel to the base. So shapes formed with a horizontal cross section that's parallel to the base. Okay, that's what's going to happen here. It's parallel to the base. So right here we have a cube, and here's the cube, and we're going to cut it parallel to that base. And it's really hard with just one hand, so bear with me. So I'm going to slice it. See how it's parallel to the base? Sliced, and after it's sliced, it forms a square. Okay. So with that horizontal cross-section parallel to the base, you would end up with a square. So right here, you're going to write the word square. Okay. So now you have a shape right here. We're going to have a cross-section, a vertical cross-section, and that vertical cross-section needs to be perpendicular to the base. So if you see the base right here, you want it to be perpendicular, so we're going to cut it. And once we cut it, you'd end up with a square. Your cross-section is a square. So write the word square right here. Okay? All right. Next up, we have a rectangular prism. So right here's a rectangular prism. It's sitting like this. We want to slice a cross-section parallel to the base. So you're going to slice it going that way. And once you do, and I take it apart to give you the cross-section, you're going to see that it's supposed to be a rectangle. So I want you to write the word rectangle right here. Okay? Something for when you're studying, you might want to try to draw a horizontal plane that's parallel to the base on all these, so it matches what it's indicating right here. Over on this column, you want to try to draw a perpendicular to the base, a cross-section that's perpendicular to the base to help you match up what's going on here, okay? All right, so here is another one, rectangular prism. And we're going to cut perpendicular to the base cross-section, and you'll see that you'll end up with a square, or you can actually end up with a rectangle too, okay, depending on the dimensions of that. So write square or rectangle right there. Okay, now we have a rectangular, oh, we already did that one, didn't we? Rectangular prism, I didn't move that. Okay, now we have a triangular prism, and here's the triangle, like an aerial view of it looking like that. It's sitting like this. And we're going to cut a parallel to the base, a cross-section. So once you do that, you'll see that you come up with a rectangle. So I want you to write rectangle right there, because that's the shape that you would get. Okay, this next part is a little bit complicated, because we want to have a cross-section that's perpendicular to the base, and it's got to have that vertical cross-section that's also perpendicular to the base. So there's one way to slice it, looking at it like this, slicing it going straight down like that. See how that would be perpendicular to the base? Well, the shape that you would get right there is a rectangle, okay? Another way that would also be perpendicular to the base is slicing it, let me find my, like this. This is also perpendicular to the base, and you would get a triangle. So for this one, I want you to write triangle or rectangle, okay? Based on what we get out of it. Okay, the next one is a cylinder, and we're going to do a horizontal cross-section that's parallel to the base. So you're cutting it, and once you cut it, you would end up with a circle. So I want you to write the word circle right there. Okay, whoops, this one came apart. Okay, again, we're also going to have a vertical cross-section perpendicular to the base. So we're going to cut that, and once you slice it, you're going to see that you have a rectangle. Or it could also be, a square based on how tall that that cylinder is, okay? So if it's the height is the same as that diameter, then you're going to have a square. Okay, so I'd write rectangle or square right there. Okay, now the next page, I want you to go ahead and write down what these shapes are called. You'll see that there's blank spots right there. So this shape right there, that's called a square pyramid. So I'll write square pyramid right there. Okay, this shape right here, you can tell by the base. See, the base right here was a square, so it's a square pyramid. The base right here is a rectangle, so this is a rectangular pyramid. Okay, this base right here is a triangle, so it's a triangular pyramid. Okay, and then this right here, this is a cone. Okay, so let's go ahead and add that part right here that you are doing a horizontal cross section that's parallel to the base. Over here, you're going to do a vertical cross section that's perpendicular to the base. And I'll go ahead and show you the cross sections. So a horizontal cross section parallel to the base, you're going to chop it, and this is your shape right there. You should write the word square right there, okay? Because that's what you get. You get a square. Okay, when you do a vertical cross section that's perpendicular to the base, see there's the base, you can go perpendicular to it, take a look at it, and you end up with a triangle as your cross section. So write the word triangle right there. Okay, right here, this is supposed to be a rectangular pyramid, see the bottom? And we're going to slice it horizontally, parallel to the base, so chop it like that. Let's take a look at its cross section, and you end up with a rectangle. So write the word rectangle right there. Okay, now right here we're going to be slicing it vertical, and that's going to be perpendicular to the base. Just right down the middle right there. On all these I'm going right down the center, okay? I'm not doing anything like off to the side or anything. I'm doing right down the center. If it was off to the side, I'm sure you could imagine that it would be a little bit different. Okay, and we're ending up with a triangle after that cut. Okay, right here we have a triangular pyramid, and we're going to cut it like horizontal, parallel to the base, and you end up with a triangle. So write the word triangle right there. Okay, right here, we're going to do a vertical cross section perpendicular to the base. When you chop it with that plane, you also end up with a triangle. Okay, so write the word triangle right there. Okay, now we have a cone. That's a cone, okay? And we're gonna chop it parallel to the base. After we've done that, you'll see that we end up with a circle. So write out the word circle right there. Okay, right here, right down the middle, right there, vertical cross section perpendicular to the base, and you end up with a triangle. Okay. So write the word triangle right there. Okay, before we go explore these types of shapes right here, I want us to do these notes right here. It's a review for many of you. And, well, here we go. So a closed two-dimensional shape with straight edges. So it's closed, two-dimensional shape, and it's got straight edges. And they're named for their number of sides. They're called a polygon. Okay? And there's two types of polygons. There's concave polygons and there's convex polygons. Concave polygons would look like this. Okay, they have straight edges still, and they're closed. Okay. Straight edges, and they are closed. Okay, and here's examples of convex polygons. Straight edges, but they're closed. Okay, and I wanted to see if you can see the difference between them. Something that I used to remember what concave polygons look like is I think, oh, there's a cave. So I'm like, okay, here's some caves. There's some caves in these. Concave polygons have caves in them. Convex polygons, they don't have any little caves in them. Okay. So now we're going to go into the polygon's name. So a three-sided polygon is called a triangle. Specific types of triangles. If you name triangles based on their angle measurements, you have right triangles, you have acute triangles, and you have obtuse triangles. If you name triangles based on their lengths of their sides, you have isosceles, That's when two of the lengths are the exact same. You have equilateral triangles. That's when all the side lengths are exactly the same. And you also have scalene triangles, and that's when they're all different size lengths. That says scalene. Okay, four-sided polygon is called a quadrilateral. And more famous quadrilaterals that have, a specific name would be like a square, rectangle. We've heard of, trapezoids have four sides. Rhombus. You could say parallelogram. But I'm just going to write ETC, etc. because there's a lot more and I can't fit them all in that space. Okay, five-sided polygon is called a pentagon. A more specific type of pentagon is called a regular pentagon, and I'll go into more detail about what that means. Okay, six-sided polygon is a hexagon. And a more specific one would be a regular hexagon. Okay, seven-sided is a heptagon. And a specific one would be a regular heptagon. An eight-sided would be an octagon. And its more specific name would be a regular octagon. Nine-sided is a nonagon. Okay, 10-sided is a decagon. Okay, so now is where I'm going to explain to you what this regular thing means, okay? Actually, before I do that, I'm going to ask you what this is called. This is called a hexagon. And this right here, it's also got six sides, but this one's called a regular hexagon. So I think you can maybe kind of come to a conclusion about what regular means, okay? That means that all sides are equal in length, and all angles are equal in degrees. Okay? And also, if you look specifically, if they just give you something that looks like this, and you see these matching little tick marks like this, that means that this side length is the same as this side length, is the same as this side length, same. And if you see these little matching tick marks with the arcs, that also means that all those angle measures are exactly the same. All the ones that have the matching ones are all equal, okay? So if you're curious about why I just went over this, that you might have, you learned it in a previous grade level, if you're curious about that, you can use those to help you name weird-looking prisms and pyramids, which you'll see on the next page. Your summary asks, what do matching tick marks on angle arcs mean? So see these matching tick marks right there on the arcs of those angles? What does that mean? Okay, so again, we're going to be slicing parallel to the base and perpendicular to the base for each of these. But you'll notice that some of these are blank over here, and that's where we're supposed to name them. So here, this has got 5 sides, and it's a prism, so it's a pentagonal prism. Here, this also has 5 sides, and it's got a pointy thing, so that's a pentagonal pyramid. Right here, you'll see that it's got 6 sides, and it's shaped like that. That's a hexagonal prism. And then you'll see here, it's really hard to see because it didn't photocopy correctly, but right here, there's 5 sides, and I just told my class to assume there's matching on the other side, so that would give this 10 sides. So this is called a Deco Gonal, and it's a pyramid because it's pointy, pyramid. Okay, now this one I don't have I don't have the Play-Doh shapes of them, so you're just going to have to visualize it and try to do it yourself. So you're going to be visualizing like a slice, a horizontal cross section parallel to the base, going like that. made up of a plane. I got a pentagon. And when I slice this one, right here, vertical cross-section perpendicular to the base, I get a rectangle. Here, what do you think you get when you slice it that way with a plane? I got this. Okay, and then when you slice this one right here, right through the center going down, vertical cross-section, perpendicular to the base, I ended up with a triangle. In my head, I don't know if that's what it really looks like. Okay, here another slice. This, I would get a hexagon. Here, slicing with a cross-sectional plane, vertical cross-section perpendicular to the base, I'd get a rectangle. Okay. Right here, going that way, I would get a decagon. Right here, going that way, I would get a triangle. Okay? All right. Try these. I actually pulled some of these from the interim assessments modeled after the SBAC. Pause the video and see if you can do this on your own. Okay, here's the answers. Select all figures that can be formed by horizontal cross-section parallel to the base of the cube. Okay, I could get a square. I don't get a trapezoid. A square is also a type of quadrilateral. And line segment, I don't really get that. Okay? Here, if you slice a square pyramid diagonally shown, what shape do you get? So like slicing it like this. The little ninja showed us this one. It's a trapezoid. And if you can't picture that based on my silly drawing right here, rewind this video and watch the little ninja guy. He also helped you with this one. If you slice a cylinder diagonally from the top edge, what shape should be formed? So it'd be kind of like this, like that. And if you look at it, that's going to be an oval, or I've heard it called an ellipse. Okay. Your summary asks, what's the definition of a cross-section? Slicing 3D shapes. And I'm going to show you the answers to that, but before you do it, I want you to take some time and determine the two-dimensional shape that would be created if the 3D shape were sliced as shown. And I want you to actually draw the picture, okay? So pause the video right now, and now here are your answers. Okay, have a good day. Bye.